Imagine now we have yet another requirement arrive, a very reasonable requirement. People want the ability to enumerate through a buffer of any type. That is, they want the ability to write a for each loop and say for each item in the buffer, we want to do something interesting with that item. At this point in time, however, this will be a compiler error because buffer is not enumerable. It doesn't have a public method called getEnumerator. And this is a reasonable requirement because most collections are enumerable. You can write a for each statement for an array, for a list of T, a queue, a stack, a dictionary. They're all enumerable. So why not our buffers too? Sometimes people need to do more than just read or write. Now there's a few different ways to make our buffers work with a for each loop, but one generally accepted practice is to use the generic interface IEnumerableT. IEnumerableT is one of those interfaces in the .NET framework where if one day it mysteriously disappeared from assemblies across the computers of the world, there would be massive problems with civilization. It's just that important. Nearly every generic collection implements IEnumerableT. All the basic link query operators are built on top of IEnumerableT, and even strings support IEnumerableT because one way to look at a string is to look at it as a collection of characters. So we want to support IEnumerableT too. Now the question is, where do we want to support it? Do we want to say that a buffer of T implements iBuffer of T and IEnumerableT? Well, that could work. It's certainly syntactically legal. However, it would be better if we just said that anything that is an iBuffer has to be an IEnumerableT too. That way all of our buffers are guaranteed to have a getEnumerator method. And by having this interface definition here, buffer, since it is a concrete type that can be instantiated, needs to satisfy all the requirements of IEnumerableT. If I go to the definition for this interface by hitting F12, I can see that IEnumerableT needs a method called getEnumerator that returns an IEnumerator of T, another generic interface. But this is going to be very easy to implement. Ignore the out keyword for right now. We'll come back and talk about that later. The only other thing I want to point out, in addition to implementing this method, getEnumerator that returns IEnumerator of T, we also have to look at IEnumerable, because anything that is an IEnumerable of T is also an IEnumerable. This interface also demands a getEnumerator method, but it returns an IEnumerator, not a generic type, just IEnumerator. IEnumerable of T returned a generic IEnumerator of T. If that's confusing, it's okay. We'll see how easy it is to implement in the code. So the first thing I'll need inside of my buffer class is a public method that returns IEnumerator of T, and it's called getEnumerator. And there's a couple different ways I could implement this. One way I could do it is simply to forward that call to the queues version of getEnumerator. And that's very simple. If for some reason I wanted to massage the data, I wanted to filter the data, I wanted to inspect the values that were being passed back through this IEnumerator of T, I could write my own for each loop inside of here. For each item in the queue, this is where I could inspect it, perhaps change it, and then ultimately I would yield return that item. Yield return is that magic C# syntax that will automatically build the state machine to implement IEnumerator of T for me. It allows these items to be handed back one at a time in a lazy manner. So that's another approach to building getEnumerator. But I also need a getEnumerator method that returns IEnumerator without the generic type parameter. That's to satisfy the IEnumerable interface. Just to prove that, let me do a build real quick. And you can see the error is that buffer of T does not implement IEnumerable.getEnumerator, which is fine. We can fix that easily. So let me show you what you might try first. You might try to just write a getEnumerator method that returns IEnumerator from the system.collections namespace and do that without using the generic type parameter. Unfortunately, if I do a build now, what the C# compiler sees is two methods with the same signature because the return type is not part of the method signature. It cannot distinguish a method. The C# compiler just sees two methods, the same name, same number of parameters, which is 0, and is essentially telling me I have a duplicate method. So the trick that we usually use to implement this particular method, the getEnumerator method for IEnumerable, is to do so using explicit interface implementation. So I want a getEnumerator method that is only callable through the interface IEnumerable. You have to have a variable type that way, or you have to use a cast in order to get to that method on a buffer object. And the other thing that I can do inside of here is simply say return getEnumerator. What we're doing is calling this version of getEnumerator. We're doing that because we're invoking this getEnumerator through the this reference implicitly. And since the this reference is not an IEnumerable interface, we'll be sure to get this public method on the object, getEnumerator, where we have our own code with a for each and a yield statement. Let me do a build. And now my build succeeds. Back here in the program, our for each loop now works. And if I actually take this code and move it below where we're processing input, it might output something interesting when I run it. So let's enter a 2.1 and a 3.4 and a 6.2. Hit enter to end this. And you can see it echoes those numbers back to me. And then it still seems to be properly summing them up. So we've now implemented IEnumerableT, both on our buffer and also our circular buffer, since it inherits all of this from buffer of t. And that's good. IEnumerableT is a great interface to support when you're building a data structure that is like a collection.